All right, welcome to lesson 5. So this lesson is on exponent rules. So we did the exponent rules in grade 9, but we've added in the negative exponent rule. Um, and we're also going to be dealing with fractional exponents today. So before we get started, because we're going to be learning fractional exponents, we need to brush up on our fraction rules for solving. So I've got a half plus 3/5. So remember that when I am adding fractions, I need common denominators. So I look what is a common denominator between 2 and 5? Well, 10 is. So basically multiply this one by 2 over 2 and this one by 5 over 5. So I get 5/10 plus 6/10 is 11/10. Okay. 2/3 times 9/14. So we know that when we're multiplying, we can just multiply across the top, multiply across the bottom, but we need to double check if we can reduce our fraction in the end. A better method is to look for opportunities to reduce. So we take a look at this too and look at our denominators anywhere. Remember, we only reduce on multiplication. It cannot reduce with 3, but it can reduce with 14. So this becomes 1 and 7. And then we take a look at the number 3, and we look at our numerators to see if it can reduce, and it can go with the 9. Oops, that's going to become a 1. 3 divided by 3 is 1. 9 divided by 3 is 3. So now if I multiply what's left, I have 1 times 3 is 3, and 1 times 7 is 7. So the answer to this is 3/7. Okay, and then I have 3/8 squared. Remember that has to go applied to both of those things. So 3 squared is 9, 8 squared is 64. Now, keep in mind that you do have a fraction button on your calculator that you can use to check these. So if you go half plus 3/5, you end up with 11/10 on your calculator. All right, so here's just a quick review of our exponent rules from grade 9 with the new one added in. So remember that if we're multiplying with like bases, we add the exponents. If we're dividing, we subtract the exponents. The power to a power, so if I have, and the way that I remember this one is in between these two powers, there's a bracket, okay? And in math, a bracket means to multiply. So I multiply my two powers in that case. If I have, and we've dealt with this one already, if I have an exponent on the outside of a bracket, that exponent must get distributed to everything inside of the bracket, whether it's multiplying or dividing. It has to go to everything. We know that the zero exponent rule at anything to the power of 0 is equal to 1. We just learned the negative exponent rule. If it's negative, I put it on the denominator of the fraction, and we already have looked a lot in this unit at the fractional exponent being in radical form. So we're going to go ahead and practice quite a few. I have like 15 examples for us to go through using these exponent rules, and then you'll get a chance to practice them on your own. Okay, so we're being asked to simplify these. These first few examples I have are not with negative exponents or not with fractional exponents. They're just a review of kind of grade 9. We will deal a lot in variable basis, like letter basis, and actually I find the letter basis easier to work with than the numerical basis because there's less numbers for us to look at and get confused by. So in number 1, I'm multiplying with like bases, so I add my exponents. So this becomes x to the power of 5. Okay, so you can think of it like that. You can also think of it as this means x times x times x times x times x times x. So I have 5 x's all together. Though when we get into the fractional exponents and negative exponents, you may need to think of them as the actual rules themselves. Okay, and in number 2, I've got a power to a power. So in between those exponents, there's a bracket. That bracket means to multiply. So it's going to become 2 to the power of 10. And in number 3, I have m to the 5 over m to the 3, so 5m's on top, 3 on the bottom, which gives me m to the 2. I subtract those exponents. Remember, you could also look at that one as having 1, 2, 3, 4, 5m's on top, 1, 2, 3m's on the bottom. Cancel, cancel, cancel. I'm left with 2m's, which is m squared. All right, number 4, so I have a negative exponent, so that has to go down to the bottom, become positive. I need a 1 on top because you always have to have something there. On the outside, that has to go to everything on the inside. Okay, and then I've got this 2/3 to the negative 3. So if you remember, we can either distribute that to everything inside, or if you remember, we can make this, remember, reciprocal or fractional base and make this a positive exponent. So 3/2 to the positive 3. So our answers are going to be done if all of our exponents are positive and we've gotten rid of any duplicate bases. Okay, so let's look at a few more that are going to get a little bit trickier. So starting to bring in fractional exponents. So I've got x to the 2/3 times x to the 3/5. So the rule doesn't change. I need to add my exponents. The problem is here that my exponents are fractions. So I need to 2/3 plus 3/5. So these will become 15s. So if I multiply this one by 5 and this one by 3, so I have 10/15 plus 9/15 is 19/15. So this becomes x to the 19 over 15. Remember, you could also take your calculator, go 2/3 plus 3/5. It's going to give you 19/15. W to the 7/8 over w to the -3/4. So the way that my brain works is I actually like to move all of my negative exponents first. I like to deal always in positives. I feel like I'm less likely to make a sign error. So I would actually move this -3/4 up to the top, and this would become w to the 7/8 and w to the 3/4. Okay, now I'm multiplying. I'm going to add the exponents, so I need to go 7/8 plus 3/4, which is 7/8 plus 6h, which is 13/8. So I've got w to the 13/8. Okay, and then I've got w to the 3/5 to the 20/9. So I'm multiplying my exponents. Now multiplying, I can multiply the top, multiply the bottom, reduce in the end, or I can cross reduce here. This becomes 1 and 3. 5 divided by 5 is 1, 20 divided by 5 is 4. So I end up with w to the 4/3. Okay, so there's some dealing with some fractional exponents. Now let's use our rules and deal with some negative exponents. So again, we need to make sure, I always like to move all of my negatives and make them positive first. So I'm going to move that n to the -2 up to the top. So I'm going to leave my n to the 4 and my 4, and I'm going to move my n to the 2. And then I need to simplify that. So that's going to become n to the 6/4. Okay, in this next example, number 11, everything is positive except for the q. So that's the only one that's going to move. So I'm going to leave p to the 3, r, q to the 2, and I'm going to put q to the 4. Okay, so I've gotten rid of my negative exponents. I need to also get rid of any duplicate bases. So I've got q's here, right? And so now I think of it as, where are there more? Well, there's more on the bottom by 2. Okay. So that is one way to do that. You could have also just, in the beginning, added your exponents here. So I'll show you, if I was to do it that way, it would look like this. So you would go p to the 3 r q squared, and then add together the 2 and -4, which would give you -2, and then move the negative down to the bottom. Okay, so you get the same answer either way. I like to get rid of the negatives first just because I feel like I'm more prone to a sign error. All right, let's take a peek at number 12. Okay, so we can again do this one of two ways. You can either reciprocal your base and make your outside positive exponent positive. We kind of still need to follow the order of operations. So inside of here, there's nothing that can be done. So then I'm going to distribute this -3 to everything inside of there. Keep in mind there's 3 different bases. So I have 3 to the -3, x to the -3, y to the -9, because 3 times -3 is -9. Now those are all negative, so they're all going to go down to the bottom. 3 to the +3 is going to become 27, x to the +3, y to the +9, and I have a 1 on top. So I've got no negative exponents and no duplicate bases, so I'm done. All right, let's look at these 3 more. What doesn't kill you makes you stronger. Okay, in number 13, I'm just going to zoom in here so you can see these guys pretty good. So the only thing that I need to move here is this guy, y to the -4. right? Keep in mind that we don't want to move this. This is, you can have a negative coefficient. It's just the negative exponents that need to move. Okay, so I like to always move everything that's negative and make it positive first. So I have 3x to the 4 and negative yx to the 4. And that y to the negative 4 will come down to the bottom and become positive. So I've got rid of all my negative exponents. Now I get rid of any duplicate bases. So I've got an x to the 4 and an x to the 4. Those are exactly the same and cancel away. And then I've got a y and a y to the 4. So I've got 3 over negative y to the 5. Okay, let's look at number 14. Oof. So this has got fractional exponents and power rules. Okay, so what I have here though, okay, remember those exponents are only on the x's, okay, and I see that I've got a negative exponent here, so I'm going to move this guy up to the top. So this will become, I'm just going to keep everything the same, so 4x to the half times 6x to the 5/6. Just the x part is coming up, and the 12 stays down below. Okay, let's maybe deal with our coefficient numbers. So let's simplify. So 4 times 6 is 24, divided by 12 is 2. So that all becomes 2. And then I've got multiplication all in the same base, so I need to add. Basically, I'm going to add 1/2 plus 5/6 plus 2/3. So you either take your calculator and put that in, or we turn those all into sixes. So this is 3/6 plus 5/6 plus 4/6. So that is 8 and 4 is 12/6, which is 2. So this all becomes x to the power of 2. So it started off looking so ugly, and it's actually quite nice on the end. Okay, one more example, number 15. Oof, yuck. Oh, we shouldn't actually have that attitude. We just want to take it like we always do, identify the things that are negative first. So I've got 3 exponents that need to move. Everything else will remain where it's at. So I'm going to have an x, remember this would be x to the 1, x to the 1/3, those are staying, and on the bottom, x to the 1/5 is going to stay. I need to move the x to the 1/2 down to the bottom. I need to move the 1/4 and the 1/6 up to the top. Okay, so what that means is that I need to add together these, and then we will subtract. So off to the side here, I need to add together 1 plus 1/3 plus 1/4 plus 1/6. This is a 1 over 1, so these can all go to 12s. So it's 12 over 12 plus 4 over 12 plus 3 over 12 plus 2 over 12. So that becomes 12 and 7 is 19 and 2 is 21 over 12, which reduces to 7 over 4. So on the top, I have x to the 7 over 4. Again, that's one where you may want to just take your calculator and your fraction button and go 1 plus 1/3 plus 1/4 plus 1/6. Then on the bottom, I need to go 1/5 plus 1/2. So those become tenths. This will be 2 tenths plus 5 tenths is 7 tenths. So on the bottom, I have x to the 7 tenths. And then I need to subtract 7/4, take away 7 tenths. So these will become 20s if I multiply this guy by 5 and this guy by 2. So I've got 35 over 20, take away 14 over 20, gives me, what is 35? Take away 14, 21 over 20, which is in those terms. So this becomes x to the 21 over 20. Okay, didn't kill you, but you might want to use your calculator so you could avoid kind of all of this, right? This is the one where it's appropriate to maybe use your calculator. All right, I've got some practice questions for you. Some of them are a little bit tricky. There are 12 of them there for you. And then if you want more, I've got another 30 where there are some very ugly ones, but if you love this stuff and you're going to go into pre-cal 20, the more you can practice, the better.